Hello learners, welcome to the class. My name is Khushbu and today I will be teaching you alternate segment theorem, one of the most important theorem of the topic circle. So without further doing, let's get started. This alternate segment theorem, which says that angle between the chord and the tangent at the point of the contact of tangent is equal to the angle made by the same chord in alternate segment, right? Or in another part of the another segment of the circle, right? So here we have to prove angle QBC is equal to angle BAC. All right, let's assume this angle as an alpha. These two angles are alpha, right? I mean, not exactly this. The first angle is the alpha. All right, let's continue with the proof here. So let's do a small construction here. I would like to join OC and OB because these two are the radius, right? OC and OB, these two are the radius, right? And we know that the radius is always perpendicular to the tangent at the point of this tangency, at the point of this contact. OB is the radius that is perpendicular to the tangent PQ, and we know that this radius is always perpendicular to the tangent at the point of this contact. So here this angle is 90 degree, correct? And this angle just we have assumed as an alpha. So this tiny angle OBC would be what? This angle is going to be 90 minus alpha, and similarly this angle is also 90 minus alpha because OB is equal to OC. It means triangle BOC is what kind of triangle is this? Isosceles triangle. Let's apply the angle sum property here in this triangle BOC. Sum of all, that says that the sum of all the angles is always 180 degrees. Sum of all the angles in a triangle is always 180 degree, right? So angle BOC would be what? Angle BOC, if I talk about the central angle, BOC it would be 180 degree minus 2 into 90 minus of alpha. All right, so it's 180 degree minus of 180 plus of 2 alpha. This 180 will be 0, 2 alpha. So this central angle is coming as how much? It's 2 alpha, right? Now we know that in a circle, angle made in a triangle is a very important property, again a theorem, right? The angle made by an arc at the center is always double of the angle made by the same arc at the circumference or at the circle. So if this is 2 alpha, this by the theorem, this angle BAC is going to be the half of angle BOC, and that is half of 2 alpha. 2 alpha, that is nothing but the alpha. So that's what we had to prove. We had to prove this angle is equal to angle QBC. That's what we had to prove. Angle Q, this angle QBC is equal to angle BAC. All right. So that is the proof of what? Alternate segment theorem, correct? So let's go ahead and do the problem based on the alternate segment theorem. So the problem says that here in this particular problem, angle BAC is given as 30 degree. We have to find out the angle ACD. All right, we need to find out the angle ACD, correct? Here I could see CD is the tangent, CD is the tangent, and the required angle that we need to find out is the sum of two angles. The one angle is angle ACB. So I could write it here as an ACD is angle ACB, plus of angle BCD. This is the sum of these two angles, right? And to find out the angle ACD, this is very standard angle. Why I'm saying the standard angle? Because this angle ACB, no, this is ACB. Angle ACB is the angle made by the diameter, because this chord AB is passing through the center, and if any chord is passing through the center, it is the diameter. All right, so AB is the diameter, and we know that angle made by the diameter at the circle is always 90 degree. So here angle ACB is what? 90 degree. Now, if I talk about this angle ACB, just recall the alternate segment theorem. It's nothing that we have just learned. This question is definitely based on that. No, you should identify which two angles are equal by the alternate segment theorem, right? So this is the angle made by the tangent and the chord. That's what we have learned just now. All right. So this angle will be equal to the angle made by the same chord BC in the alternate segment, that is 30 degree, right? So by alternate segment theorem, this angle BCD is nothing but 90 degree by the alternate segment theorem. Now what we need to find out? We have to find out the value of angle ACD, that is nothing but 90 degree plus of 90 degree plus of 30 degree. 90 degree plus of 30 degree, that is 120 degrees, our required answer. I hope you all understood. Thank you so much.